Hi all and welcome to the second part of the Stacks and Queues chapter, which is part of our Algorithms and Data Structures course. In this video, we will go over an algorithms problem to better understand how to use stacks, valid parentheses. This is a very popular question in interviews, so I hope at the end of this video you will have really understood how stacks make this problem easy to solve. I will add a GitHub URL where I post all the problems I'm working on and document every data structure and algorithm as well, so you can follow along my progress. Before we continue, please take just a second to like the video, as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please subscribe so that you will receive notifications when a new section of the course will be released. Now let's read the text of the problem and understand our requirements. Then we will move on to the conceptual overview, where we will learn how to conceptually solve the problem, and then we move on to the coding part of the problem. The problem sounds as follows. Given a string S containing just the characters open and closed parentheses, and we have three pairs of open and closed parentheses, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order. So just like in any programming language which uses parentheses and brackets, the rule is simple. The open brackets must be closed and they must be closed in the correct order by the same type of brackets. Now that we understood the text of the problem, and we can see here the input for each example and when it is returned true and when it is returned false, I guess you don't have to go through that, it's pretty simple. Let's go to the conceptual overview of the problem, where we will draw the algorithm and we will understand how to conceptually solve this problem before we code it. Welcome to the conceptual overview of the valid parentheses problem. We understood what the problem wants from us. Now let's draw two examples and see how would we solve this problem. Let's take a string S, which in this case takes a valid order of parentheses. Now, using a stack, there are actually two steps to solve this problem. Step number one is if the stack is not empty and the value at the top of the stack is an open bracket corresponding to a closing bracket, meaning the two brackets, the open and the closed one, are of the same type, and in this case the closing bracket, which represents the current character in the string. Then pop out of the stack, else push into the stack. And step number two, return true or false in case the stack is empty or not. Okay, now we have our two steps. I hope I could make myself clear, especially with the first step, as it is a bit more tricky, but we will go through two examples. One example is a case where our brackets are open and closed in the correct order, and another example where they aren't open and closed in the correct order. So let's start with the one in which they are open and closed in the correct order. I'm gonna take my string here and we can start iterating. We said that we have a string, we have to iterate through the string, and we will use a stack. So let's draw a stack here and we will start iterating through the string. So I'm gonna say first character chart 0 is a open bracket. Now we said if the stack is not empty, in our case the stack is empty, we push the value into the stack. So the first value in the stack will be our open bracket. We move forward with our iteration. Char at 1 is an open bracket. We again check and we see that our stack is not empty this time, and we want to see if the value at the top of the stack is an open bracket corresponding to a closing bracket, which is in our case char at 1. Now, how do we define if we have an open or a closed bracket? Well, in order to achieve that, we need to use another data structure. In this case, we will use a map, let's call it a dictionary, in which our key represents the open bracket and our value represents the closing bracket. And like this, we know what is an open bracket and what is a closed bracket. So in our dictionary, we will have a key and a value. The key, as I said, represents the open bracket and the value represents the closing bracket. brackets. And now we check if our character at position 1 is a closing bracket. Well, it isn't, it's an open bracket, so we add it into the stack. Then we move to chart 2, and in this case it's also an open bracket, thus we will put it into the stack. We move to chart 3, we check into our map, and we see that in this case we have a closing bracket. We also check if the stack is empty, and it isn't. And then the last check we need to make is if our closing bracket is matching the open bracket at the top of the stack. And it does. Thus, in this case, we don't add into the stack, we remove from the stack, so we pop out of the stack. We move to chart 4, which is a closing squared bracket. Once again, we make the same two checks. Number 1, is my stack empty? No. Is the element at the top, the open bracket, corresponding to the closing bracket of our current character? Yes, it is. We pop out of the stack. And as you can imagine, if we move to character at 5, which is a closing curly bracket, we see that it corresponds, and we remove it from the stack. If we take a different example where, let's see, our string would look something like an open bracket, then we have an open squared bracket, then we have a closing bracket and a closing squared bracket. If we go through the same steps, we would see that at step number 1 we add the open bracket into the stack. At step number 2 we again add the open square bracket into the stack. At step number 3, where we see we have a closing bracket but it doesn't correspond to our top of the stack, we again add it into the stack. And the same for step number 4, where we add the closing bracket into the stack because the top of the stack is not an open bracket corresponding to it. In this case, we iterate it through the whole string and the stack is not empty. Thus, in this case, we would return false. Now, if we look at time complexity, is O of n, because we go through the string once, where n is the length of the string, and space complexity is also O of n, because we use a stack which contains all the elements of the string in a worst case scenario. I hope that this drawing helped you understand the steps, and you can also visualize how the use of a stack helps us solve this problem in O of n time. We will move now to the coding part to reinforce what we discussed here and see how we can apply this in code. We will start with the Python implementation of the problem, and the first condition we need to implement is if the length of our string is less than 2 characters, then we return false. I guess this is quite obvious as it cannot be a pair of parentheses, thus it's not valid. Now the next problem we want to solve is how do we determine if a character in our string which represents a parenthesis is an open parenthesis or a closed one. For this we will create a map or a dictionary in Python in which we will define the pair of parentheses. The key will be the open parenthesis and the value will be the closed parenthesis, and we do this for all 3 pairs of parentheses as we are only given these 3 options. We also want to define a stack which will hold our parentheses and will help us in solving this problem. The next step is to iterate through the string, and I'm gonna say for each element in the string. Now this is the key part of our algorithm. So we have to make a choice if we will add something to the queue or if we will pop something out of the queue. How do we decide to pop something out of the queue? Well, if the length of the queue is higher than 0, and now we have to say if at the top of the queue I have an open parenthesis and the next value in the string it's the closed parenthesis of the same type as the one at the top of the queue, then I want to pop because I have a pair. I can just remove it from the queue, as you also saw in the drawing. So I'm gonna say, how can I identify now if the parenthesis is open or is closed, and how can I define if they are pairs? Well, that's why we define our map. So I'm gonna take from my dictionary the value at the top of the queue. So I'm gonna pick at the top of the queue and take the value corresponding to that key if I have one. So I'm gonna say retrieve the value from the dictionary according to the top of the queue, and this will be length of temp -1. Now there is a possibility that I don't have an open parenthesis but I have a closed one. In this case I don't have a key, this is not a key, thus I will define a default value which is none. By this what I just said is this a closed parentheses, because we know that the keys are the open ones and the values are the closed ones. If this is a closed parenthesis and it matches to the element, then I'm gonna pop from the stack. Else, I'm gonna append to the stack. And this is all basically. And I'm gonna return true or false. If the stack is empty, it means that every open parenthesis has a matching closed parenthesis and it's in the right order, because this is basically ensured by the if inside the for. And if the stack is not empty, then I will return false. It runs, let's submit it as well, and it works very well. Now we will continue with the Java implementation of our algorithm. We will start by checking the length of our string. If it's less than 2, then we don't have a valid parenthesis combination. Thus, we will return false. The next thing we need to do is to define how do we know if we have an open or a closed parenthesis. And for that, we will declare a map. We will call it parenthesis dictionary. Now, in my parenthesis dictionary, I will put as key the open parenthesis and as value the closed parenthesis. And I also need to declare my stack of definitely strings. I'm gonna call it temp. Now the next step is to iterate through the string. And now I have two options. I can either add something to the stack or remove from the stack. And given our condition that the input has to be a valid open-closed parenthesis combination, the first thing I'm gonna do, I'm gonna first check if my stack is empty. If it's not empty and at the top of the stack I have an open parenthesis and the next element that is in the string is a closed parenthesis of the same type, then I found a pair. So I'm gonna remove it from the stack. How am I gonna define that? I'm gonna check if the top of the stack is an open parenthesis. So I'm gonna check if it's a key in my map. I'm gonna do this by picking. We will not pop because then we will remove it from the stack. We don't want that. And in case it's not a key, then the default will be, let's just say, a star. Now, in case this is a valid key, I'm gonna check if it equals the value of the current character. And if it does, I'm gonna pop the value from the stack. Otherwise, I'm gonna add the value to the stack. I'm gonna push it into the stack. And in case the stack is empty, I'm gonna return true. Otherwise, I'm gonna return false. So I'm gonna return temp empty. Yeah, it works. Let's also submit it, and it also works well. I really hope that you enjoyed this segment of our algorithms and data structure course. If you did, or if you have any suggestions, please take a moment to leave a comment below. Next week, we will move on to queues. Don't forget to like the video, as it helps with the YouTube algorithm so that more people can benefit from this course. Also, please don't forget to subscribe and press the bell button to receive notification when the next chapter of the course will be released. Thank you for watching, and I will see you in the next one.